Hello guys and welcome back to this amazing channel. This is Abhinav. Today we'll discuss about the problems of the video of the contest Codeforces Round 943. So 943 is actually an Division 3 round, right? It's a Division 3 round. I was participating in this round. I tried for first half an hour and after that I got some work and I left the round in between. So if you will see the standings, I solved some 3 problems in the first 3 hours and then I left the contest. Okay, in first 15 minutes itself. Uh, because it was not rated for me. It doesn't affected my rating and all. So, and then the next 2 problems I upsolved. I was trying to like solve the remaining problems also. They were also not very very difficult level. I can solve them, but it will take a lot of time to upsolve them, and that is why this recording will got late. So that is why I didn't opt for it. Uh, Cool. So let's have a very quick discussion of all the problems one by one. The very first is a problem called maximize. The problem, so you will see that all the 5 problems are of brute force. All the brute force problems are there. This fifth problem is a little bit of uh, uh, thinking based problem. Otherwise, all the first 4 problems are totally brute force problem. So the solution will be very easy. The first problem says that you are having an integer x. Now you have to find an integer y which should be between 1 to x such that the GCD of x comma y plus y is maximum possible. Ab you may think, okay, how I can solve this problem, but it's a very easy, straightforward question with a brute force kind of thing. So if you will see what is happening here, I'm first taking input of x, and then simply for finding y, what I did, I simply took a loop from 1 to less than x because you can see the range of y is from 1 to less than x, and then for every such I, I'm finding the value of this xxx, which is basically GCD of x comma I plus I, where I is basically this y I'm representing. And for whichever such I, this answer is greater than the current answer, I will update the value of answer and I will make that I equal to y. So that's the basic thing I'm doing for this particular question, right? I hope it is clear. Next comes the problem number B, which is prefiquence. This problem is again a very basic problem of brute force only, but this is little like this is better problem. The problem says that you have a string A, which is a binary string, and you have a string B, which is again a binary string. Let's say string A is 10100110101. Let's say string B, it can be of different size. It can be, let's say, 01100100100110110 and so on. Okay, up see guys, what we will do, they're asking us that you have to find a prefix string of this A. Prefix string means starting from A, like this is a prefix string, this is a prefix, this is a prefix, means starting from index number 0 till a particular index, and you have to find the longest some such prefix such that it is a substring of this string B. It is a substring. No, sorry, not substring, subsequence. It should be a subsequence. You have to find a prefix of A, which is also a subsequence of B, a longest prefix of A, basically, right? Though, guys, how you can actually do it? What you can actually do is, I will, I will took 2 pointers, right? I will took 2 basic pointers. First pointer I will took here. This is pointer I. Second I will put here. This is pointer J, right? Ab, what it will do is uh, it will say, okay, for example, you have to find, okay, this numbers of A should actually make a subsequence in B. Subsequence can be, is not continuous. It can be, there can be breaks in the subsequence, right? There can be breaks in the subsequence. So what actually you can do is you can iterate through B, and whenever there is a character that matches with the current character of A, you can increase. If you will see currently, this 0 is not matching with this 1. That means, okay, it's not matching. Now you will increase this J pointer. J means the pointer of B. Now you can see, now they are matching, means this 1 is actually present in B also, means that can be a, this is obviously a subsequence. Okay, so what will happen, now you will increase I also and J also in this case, and you will consider we got a subsequence 1. Then now it hits 0, hits 1. No subsequence, right? Again you move forward. Now here 0, 0 is there. Sorry. Yeah. Now you can see 0 and 0 is there. That means we got one more 0, and now both of them will increase. Okay, I will reduce the size of both A and B. Otherwise, it will be very long continuity, right? Let me stop. Yeah. Up, if you will see, now it got a 1. Okay. Up when it got a 1, here it's a 0, it's a 1. Means there's no match. Just move J. Now we got a 1, and here also it's a 1. Means again we got a subsequence. So both J and I will be increased. Now it's a 0 and 0. Again both I and J will be increased. Now it's a 1 0. No match. It's a 0 0. Yes, they will be increased. So both will be increased. I also and J also. Now it's a 0 1. And now finally this J will go out of the loop. Now you will see this is the final length 5. So I is currently as 5. That means there is a prefix is a string of length 5, which is 10100. That is actually a prefix, which is also a subsequence of this B. You can see it is also a subsequence of this B, right? So this is all you can find. If you will see, I have done the same thing. I have implemented the same thing here. What I'm doing here is that I am simply taking two strings A and B. I'm taking two integers A, I, and J, which is 0. Initially, they are at the 0 index, right? Now, while I is less than n and J is less than m, because both should be in the range, I'm taking. So, if AI is equal to Bj, means we got that number in Bj, means that can be the part of a subsequence. Increase both I and J. Else, just increase J. That is what we were doing here. And then finally, whatever the I will be is the answer. For example, here the I ends at 5. Then 5 is the length of the prefix substring, means 5 characters are before that, right? That's the thing. Let's move forward. Problem number C was even better. So problem number C was assembly via reminders. So guys, what I actually did is, now see, here they are saying that you are given with a array x. So you are given actually with the indexes x2. Basically, array x is there, which has indexing starting from 1 2 3 4 5 6 7 and so on. What you are given with, you are just given with some, you are not given with the first character, first element of this array x. You are given the remaining numbers, and that remaining numbers will be between 1 to 500. They will be between 1 to 500. That's an important thing, because this whole question was all about constants, right? So for example, this is 5, this is let's say 106, this is let's say 20, this is let's say 7, this is let's say 431, this is let's say 500. These are the elements of this array x. Now you have to create an array b of same size from 1 to 7, like whatever it is. Here n is 7, such that ai modulus ai minus 1 should be equal to xi. Means this ai modulus its previous number should be equal to 500. Okay, अब देखो guys, the thing comes here is they are saying that the range of ai should be 10 to the power 9. So this is actually also observation based problem. Means the value of this a array can be between from 1 to 10 to the power 9. Now guys, if we can do this, it will become easy for us. What I will do, because the numbers of this is just 500, what I can do, I will make this last value of array whole 10 to the power 9. Whole 10 to the power 9. Because it can be. Now what I will do, I will make this as 10 to the power 9 minus 500. Understand? Minus 500. Whatever it is. 1 2 3 4 5 6 7 8 9 minus 500. It is 999999500, and this is 1 and then 9 times 0. If you will actually find the mod of ai minus 1 this with this, what I am saying, if you will actually find the mod of 1 2 3 4 5 6 7 8 9 9 modulus what? Modulus this, you can see we are getting 500 only. We are getting nothing but 500. Why? Because obviously this number is less than this number. So if you will find the mod of this 10 to the power 9 with this, it is 500 less. But if you will divide, let's say, 1000 by 950, what you will get? You will get a mod of 50 na, the difference of them. So when you divide two very large numbers with a very small difference, means when you divide two very large numbers, let's say you are dividing 1 lakh with 99,995. So numbers are very large, difference is very small, 5. When we divide it, the remainder comes as the difference only, because they are divided with a quotient 1 only, and remaining their difference will be the remainder. Similarly, when I'm giving here, okay, what I'm saying here, make the last number as 10 to the power 9 and last second number is difference of that. So whatever is there, subtract 500 from it. Now here, from this number you will subtract 431 more. It will be 10 to the power 9 minus 931. Here you will subtract 7 more. So it will be minus 938. Here it will be minus 968. And because these numbers of this array X cannot be more than 500, they are less than equal to 500. And X at max n can also go up to 500. And can also go up to 500. So at max you can have a sum of this 2500. Oh, 25, not 2500, 2,50,000, right? So because this will be the only sum, so it can go up to this last first element of this a can go up to 10 to the power 9 minus 250000. And if you, and this is not a very big difference in 10 to the power 9. This will always give a very small remainder. Okay? The main observation is that when we divide two very large numbers with a very small difference, that difference comes as the remainder. And that is what I am doing here. If you will see the solution here, what I did is simply I took the last number of this array as 10 to the power 9. You can see here. And then for every number of array, I am actually taking the next number and then subtracting the current value of x. For example, this is nothing but 10 to the power minus n, 10 to the power 9 minus 500. This is nothing but this number minus 431 and so on. Okay. So this is how we are solved. If you will see, these constants are the main thing in this particular problem. How we are dealing with these constants. That's the very most important thing, right? Amazing, cool. Let's move to the next problem. Next was actually a good problem, which was a permutation game. Here the problem was that you are given with 3-4 things. So the very first thing that you are given is n. N is a size of the array. K are the number of operations that you can do. Right. Now you have PB and PS. So what is PB? There's a person called let's call it B only. I will not take these names. And let's call S. So there's a person named B and there's a person named S. Right. There are two persons. And you are given with the initial sum position of the persons. So PB is the position of the person B. PS is the position of the person S. Right. What you can do is, this person, there are two arrays given to you. A is the array which will tell you the point that a person will get if it is at the particular index or a particular position. And P is a permutation of the numbers from 1 to n, which will actually tell that to the next which position the person can go. So if you will see, they are saying that in each turn, so they have to actually make k turns first of all. They have to make k turns, and saying that in each turn, the person score will be increased by ax. Whatever is the value of the index, like for example, if the current person is at position x, then its score will be increased by whatever is the value of ax. Means whatever will be the value of the person at uh, the array at the key x index, right? That will be the thing. What it will do is key, this will be the score that will be increased. Next thing will be that now the player has to move. Now player has two options. Either the player can stay at the same position in the current position, or he can move to another position from x to px. That is actually a thing. That he is currently at x, he can move to px. What is px? Px is the like the value of the x index in the permutation array. Basically, from one index, the permutation array will give it another index, right? So it can basically take that particular index, right? अब देखो होगा क्या. For example, the person is currently at PB. Let's talk about the person B. So the person is initially at PB, where it can go? It can go to P of PB, means whatever is the value at the PB index of the permutation array. Then again it will go to P of PB. Again it will go to P of PB until it wants to change. Now what it can do now let's see, once okay, he doesn't want to change. Let's see, doesn't changes. He wants to be there whatever he is. Then again he doesn't want to change. Then again he changed to PB. But if you will understand one thing, when the person will want to change and when the person not wants to change. See guys, the person wants to change the index only if he thinks that he can get a better score in next some moves. Means after making some moves, after changing the position by some permutation, if the person can get good number, good score, then definitely he or she will change the position. And if the person will think कि okay, the position where he or she is currently is the best position, he will never change it. But how to check that best position? What is that best position where the person should stop, from where he should not leave? That we cannot define. If we have to define it, it will become a dynamic programming problem. Then we have to check for all the cases. But we have to solve it in the greedy because we don't have that much time. Okay. So guys, what we will do? What we will do? We will start from PB, and in every case we will assume कि what will be the score if, let's say, the person has opted to continue the remaining all the k chances in this PB only. For example, if I will say okay, the person will take all the k chances in this PB only, so what will be his score? So his score will be k multiplied by a of PB. Am I right? That will be the score if the person will choose to stay on the PB index. And if the person wants to leave, he can leave. He can just add the current store and he can leave to the next index, which is P of PB. And now again what we'll do? Again we'll ask the person whether he wants to stay here for the remaining k minus 1 chances, or whether he wants to again move to the next index. So this is how we'll take the maximum of all those conditions. So if you will see here, if you will see in my code, what I did is, see, I am simply I have implemented to a function find max. So this function is, so first of all I'm simply taking the input of the values n, k, pb, ps. Then I'm subtracting this pb and ps by 1 because they are given us in one base indexing and I want 0 base indexing, right? Now I'm taking input of the two vectors p and a, right? All the elements we are taking as the input. Now we have two functions find max, like one function find max that I'm calling two times. So first four values are constant. Last value we are giving the current position of the person. So when we are finding for the person B, we are giving PB as the initial index. When we are doing for the person S, we are finding for the, like, we are giving the PS, like the initial position of the S, person S, right? Now what this function find max does? This function basically take the current position of that person and finds the maximum score that the person can get. So initially I will take my answer as 0. So this answer will actually store the maximum score, and sum is actually the sum of the current score till now what the person has. Ab dekho guys, I did a visited here. Why I did a visited here? See guys, actually this permutation will also revolve again and again. Let me tell you why. Okay. For example, if the permutation array is like this, let's say it's 1, 0, 3, 2, 4, and this is the indexing. For example, currently the person is at, okay, I have to do some changes. Uh, huh. For example, the person PB is currently at the index number 1. From 1, let's say he opt to change. Now from 1, if you will see, it will go to 2. Now from 2, he again asks to change, so it will go to 3. From 3, it will go to 0. From 0, it will go to 4. Up from 4, it is again saying to come back to 1. But does it do? It will make a whole, cyclic order. But if we have already visited once, we know what will occur after it. We cannot make all the k moves like this. No, we have to skip some of the moves. We cannot make all these k moves like this. We don't have much time. So we will only go once in this cycle. Whenever the cycle will repeat, we will say stop. We don't want. Hey, what it will do here? It will say initially, okay, it will say, okay, first it is when it is at 1, it will say, okay, what I will do, I will take all the k moves for this a1. Now when it will move forward, it will say, okay, I am taking first move just a1 and remaining k minus moves with this a2. Now when it move for 3, it will say, okay, first two moves I took for a1 and a2, remaining k minus 2 moves I will take for a3. When it will move forward means it is saying first 3 moves I am taking for a1, a2, a3 and remaining k minus 3 moves I will take for a0. Up here similarly, first 4 moves here, remaining here. Up here there's no point. There's no point. Because here you are saying, okay, the person will take first 5 moves here and remaining moves here. So if it is taking remaining all the moves for 1, that means 1 is a maximum number, means 1 is a best number. So why take these? Initially only take all of them. So that case is already handled, right? So there's no need to move again to a point which is already visited. What I'm doing, I'm using a visited array where I'm saying initially all are false. While the visited is false of the current node where we are and k is greater than 0, what I'm doing, I'm first of all making visited current true, means we have visited it. Now I'm finding the answer max sum till now plus k into a of current, means we're assuming if we will take this current index for all remaining k operation, if we will not move, then what will be the sum? What is the sum is stored in the answer. And else, if we will actually move it, simply add the sum of the current index just once and then move to the next index of the permutation. And why I am doing -1? Because this permutation array is also 1 based. And also after every operation I will do k minus minus, right? So this is the function that I've implemented and then used it here to find the sum of b and sum of s. And based on the sum, I'm bringing the names, right? Cool, guys. So this was actually a very good problem of this particular contest. If you have still any doubt, guys, you feel free to ask that in the comment section, or you can also join the Telegram channel, right, to ask your doubts. Amazing. Ab last question comes, okay, for this particular video, which is uh, cell arrangement. Though this cell arrangement question says that you have a grid of size n into n. Let's create a grid. Let's create a grid of some size. Let's see what size comes up. Uh, so this question basically says that in this grid of size n into n, you have to actually choose n points, n cells, and you have to choose the cells such that the distance between them, the mountain distance between them, which is defined by x1 minus x2. I will tell you. So I think this is 1, 2, 3, 4, 5. This is 1, 2, 3, 4, 5, and 6. Okay, but it should be of size n plus n into n only. This is not a good. Okay, no worries. Yeah, so it's a grid. Assume it is a square grid of size 5 into 5. It's not, by the way. Yeah. So now what we will do, it is saying make n cells such that the set of distinct pairs of Manhattan distance should be maximized. means there should be distinct number of these distances. That's the basic thing. This distance basically there is a point at x1 comma y1 to x2 comma y2. Distance is mod of x1 minus x2 plus mod of y1 minus y2. Basically it is the sum of difference in rows plus difference in column. That's the basic thing. Difference in number of rows and difference in number of column is the basically this distance, right? Now देखो guys, what you will do? First of all, so you want points with different, you want points with different, what we say that, distances, right? As much as difference, different distances we can have. We want that number of points, right? So what we can actually do is, guys, first of all, let's see if we can have 2 points with, distance 1. Very simple. If we can have 2 points with a distance 1, simple, we can have the first point here and second point here. Means first point at 1 comma 1 and second point at 2 comma 1. So they will simply give you a distance of how much? They will simply give you a distance of 1. Now let's see which can give me a distance of 3. So we will see this can give you a distance of 3. Now distance of 4, this can give you a distance of 4. Now distance for 5, this can give you a distance of 5. So you can see that this is distance 1, right? These two will give you a difference distance of 1. Okay, these two will give you a difference of 2. This will be distance of 3. This is distance of 4. Now you must be thinking that, Abhinav, you can also like place this particular dot here. This will also give you 2. But why I placed it here? There's a reason. Because now we have one more pair of indexes. Till here what we got? We got, see, we got 1, we got 2, 3, 4, and this is actually, this is 4 only. This is not 5. So this is 1, 2, 3 and 4. Now if we will find this, what is this distance? This is actually 5. So we got a 5 also. We got a 5 also. So we got distance 1, 2, 3, 4, 5. Right? So means every 5 point is, at a difference, at a different there. So if you will see, so you will say that, okay, how you thought it is simply a, observation based thing. Simply you have to make multiple grid. I made multiple grids. I thought of it, how we can do that, and then we got to this idea. That's the basic thing. It's a proper observation based problem. So if you will see, what I did is, first 2 points are there only, which is 1 comma 1 and 2 comma 1. That's the basic first 2 points, 1 comma 1 and 2 comma 1. Now remaining points we are going from, starting from 3 to n minus 1 I am going. Okay. So 1 comma okay, 1 point, one thing is there. We will actually not give this point, this last point. This also I will explain you why. So I initially explained you fine, but I will give you one more way ki why to not give this point. Though guys, why to not give this point? See, 5 distance you are already getting from somewhere else. If you will see, this distance 5 you are already getting from here. So this will also give you distance 5. Okay, wait. No, okay, this will not give you 5. Sorry, I was talking about this. So see, what I'm saying is, देखो, this was the part. Okay, अब this will give you distance 1. This will give you distance 2. This will give you distance 3. This was actually for distance 4. But instead of this distance 4, what you can do, you can remove that and you can get distance 4 from here. This is also distance 4. You can see 4 minus 2 plus 1 minus 4. This is also distance 4. Ab, why I'm, not taking that fifth dot? That fifth dot I will make here. I will make here. Right? This fifth dot I will make here only. Why I'm making here? Because now this fifth dot will give completely different distances. This and this will give you uh, 5 minus 1 plus 5 minus 1, 8. This and this will give you 7. This and this will actually give you 5. And this will give you 6. This is how you can see you are getting all the numbers from 1 to 8 using this combination, and you cannot get more than 8 different in distances. That's a guarantee. And this is how you can get this. There's a So this you can see, if there is only 2 by 2 ka grid, then the answer will be very clear. Then you can simply make any two dots anywhere, not like this but this. So you can see this is how the answer will be. So you can see that what I'm doing, I'm first printing 1 comma 1 2 comma 1, because that will always be the answer, because n key value is from 2 till 10 power 3. And for remaining all the dots, if the number of dots are more than 3, so here also you can see it's starting from 3 to less than n, and this is also if we are printing if it is more than 3. Okay, for 2 dots simply this, if they are more than 2 then we have to print this also, right? So this is a completely observation based thing, how we thought of this, how we can get maximum these maximum distinct distances. This is a complete observation based thing. Cool guys, so I hope that you have got the good understanding of all these 5 problems, right? All these 5 problems. If you have any doubt, please do comment it down, or you can join a Telegram. Thank you.